Good morning, students. Kinetic theory of gases. Today we are going to discuss kinetic theory of gases. This is the plus one syllabus. So fast division, and this is useful for crash course. The first concept is gas laws. In gas laws, totally we need to discuss about 6 gas laws. First one is Boyle's law. In a Boyle's law, for a given mass of an ideal gas, generally the volume of a gas is inversely proportional to pressure of the gas. Then, what is the meaning of that? Volume and pressure both are inversely proportional, means V1 upon V2 is equal to inversely proportional, no? So P2 upon P1. So V1 upon V2 is equal to inversely proportional. That's why P2 by P1. This is the formula we are going to using to solve the problems. This can also be written as PV is equal to constant, of course. PV is equal to constant. Both are inversely proportional, means product is constant. That is the meaning. Suppose if I am going to take this formula, PV is equal to constant. So P into what is V? Mass by density. Here P is the pressure, V is the volume. P is equal to pressure, V is equal to volume. And we know that volume is equal to mass by density. That is mass of a given mass of a gas into density of a gas. That is volume means mass by density. That is equal to constant. So P in place of volume, mass by density I wrote, is equal to constant. But we know that this is the for a given mass of an ideal gas, means mass is constant. M is constant. Why? Because I fixed the mass of the gas. For a given mass of an ideal gas means mass fixed. That means M constant. If M constant, what is the relation between P and rho? P upon rho. M constant, no? So that's why it is constant. Right hand side constant, then P by rho is constant. What is the meaning of that? Let us see. P is equal to constant into rho. So constant into rho. That means P and rho both are directly proportional. P is equal to constant into rho means what? P is directly proportional to density. Directly proportional. That means P1 upon P2 is equal to rho 1 upon rho 2. So P1 by P2 is equal to rho 1 by rho 2. So this is the relation between pressure and density. This is also one of the formula we are going to using to solve the problem. So volume and pressures are given in the problem, use this one. Pressure and densities are given, use this formula. So this is one kind of Boyle's law. This is also Boyle's law in terms of pressure and density. Here pressure by density is equal to constant. That means pressure is equal to constant into rho. So pressure and density both are directly proportional. Why? Because constant and is equal to, replace it with proportional symbol. Directly proportional. That's why P1 by P2 is equal to rho 1 by rho 2. Note down, students. In Boyle's law, one more relation is also there. So pressure into volume is equal to constant. But we know that small n is equal to number of molecules per unit volume. Small n, what is meaning of small n? Number of molecules per unit volume. Means n is equal to number of molecules per unit volume, where capital N is the number of molecules. V is equal to volume. So number of molecules per unit volume is equal to small n. So from here, what is volume? Number of molecules by small n. From here, both are equivalent. Volume is equal to, from this relation, what is volume? Number of molecules by small n. What is small n? Number of molecules per unit volume. So I'm going to replace the volume with its equivalent n by n. So n by n, which is equal to constant. So n transpose to other side. P into n is equal to some constant into small n. Here number of molecules constant. This is constant. Then what is the relation between pressure and number of molecules per unit volume? Directly proportional. Here number of molecules constant. This is constant. Then what is the relation between P and N? Here what happens if pressure changes? If I am going to consider a gas like this is the vessel. If suppose I am going to consider total number of molecules is capital M. Number of molecules per unit volume means if I am going to consider a unit volume in this situation, calculate the number of molecules. So number of molecules per unit volume. If pressure changes, what happen? Gas molecules will be changes their position. That's why what happen? Number of molecules definitely in the unit volume will change. That's why number of molecules per unit volume will be changes. If pressure changes, what happen? So this is the one case at pressure P1. If I am going to consider in the same gas pressure P2 means what will happen? In this volume, number of molecules definitely will be changed. Why? Because pressure change, That's why that small n means what? Number of molecules per unit volume. That is changing. When pressure changes. That's why what happened? Both are directly proportional. That means P1 by P2 is equal to N1 by N2. Note down. Next one, Charles' law. So Charles' law is at constant pressure. That means we need to remain the pressure as a constant. Then volume of the gas is directly proportional to absolute temperature. Here temperature measured in kelvins. That's why we called it absolute temperature. From this, both are directly proportional means how to write the formula? V1 upon V2 is equal to T1 upon T2. This is the one of the formula we are going to using to solve the problem at constant pressure. If suppose I am going to consider what is the meaning of volume? Volume means mass by density. Mass by density. Volume means mass by density. Where rho is equal to density of a gas is proportional to temperature. Here what happened? Mass constant. Given mass of a gas, given mass of an ideal gas, so mass constant. Then rho and T are inversely proportional to each other. Then how to write the formula? Rho 1 upon rho 2 is equal to inversely proportional, no? 1 by 2 means 2 by 1. T2 upon T1. So this is the one more formula in Charles' law we are going to using to solve the problems. If suppose problem is related to density and temperature means use this one, volume and temperature means use this formula. We are going to get the results. Suppose one more relation, most important relation we need to discuss here. In Charles' law, at any temperature to calculate volume, we need to use the formula V naught into 1 plus 1 by 273 times T. That means at a given temperature T, volume is Vt. How to calculate? By using V naught. What is V naught? Volume of the gas at 0 degrees Celsius. Volume of gas at 0 degrees Celsius. If suppose we know that volume of the gas at 0 degrees Celsius, substitute here, and at any temperature we can calculate volume of the gas. So substitute the temperature, we are going to get the volume at any temperature T by using this relation. Note down, students. Third law, Gay-Lussac's law, or it is also known as pressure law. In this law, for a given mass of a gas, generally at constant volume, pressure is directly proportional to absolute temperature measured in kelvins. So then what is the formula? P1 upon P2 is equal to, both are directly proportional, T1 upon T2. By using this formula, we can solve the problems. If I know pressure at 0 degrees Celsius, that is P naught. Pressure at 0 degrees Celsius. We can calculate pressure at any temperature T. Pressure at any temperature. Pressure at any temperature. How to calculate? Pt is equal to P naught into 1 plus 1 by 273 times T. So if I know pressure at 0 degree Celsius, substitute here. I am going to get a pressure at any time T. That is the PT. We are going to calculate pressure at any time T. Substitute here temperature value. Pressure at any temperature. Not time, temperature. So if I know pressure at 0 degree Celsius, we can calculate pressure at any temperature T by using this formula. Note down, students. Fourth law, Avogadro's law. If I am going to consider three different gases with equal volumes, consider all volumes are equal volume, and temperature inside temperature same. All gases, different gases. This is the gas X, this is the gas Y, this is the gas Z. Different gases. Gas Z. All the three X, Y, Z gases have the same temperature T and the same pressure P, and their volumes also equal. At the time, all the three gases having equal number of molecules. Suppose your number of molecules N1, your number of molecules N2, your number of molecules N3 means N1 is equal to N2 is equal to N3. That is only Avogadro's law. Equal volumes of all gases. Under similar conditions of temperature and pressure. Contains equal number of molecules. N1 is equal to N2 is equal to N3. Equal number of molecules. That is only Avogadro's law. Note down, students. Fifth law, Graham's law of diffusion. If I am going to consider two gases, when two gases are allowed to diffuse, those two gases are maintained at the same pressure and temperature. So the two gases at the same pressure and temperature are allowed to diffuse into each other. Then what will happen? Here what happened? Both gases are maintained at the same pressure and temperature, and they are allowed to diffuse each other. At the time what will happen? So rate of diffusion of each gas is inversely proportional to square root of density of gas, density of the gas. That means rate of diffusion is inversely proportional to square root of density of the gas. Then how to write the formula? R1 by R2. R1 and R2 rate of diffusion of two gases. First gas and second gas, which is equal to, there is a square root now, so square root of rho is inversely proportional inside the root rho is inversely proportional. 1 by 2 means 2 by 1, that means rho 2 upon rho 1. This is the required formula, that is the relation between rate of diffusion and density. And sometimes he will give the molecular weight of the gas. At the time, density and molecular weight both are directly proportional. Here I mean the molecular weight of a gas. At the time, this formula how to change? R1 by R2 is equal to square root of. Why? Because density and molecular weight both are directly proportional, no? So in place of rho 2 by rho 1, replace the molecular weights. That's all. Why? Because both are directly proportional. In place of rho 2 by rho 1, replace M2 by M1. That's all. M2 by M1. This is the relation between rate of diffusion of each gas and their molecular weights. According to given data, we are going to be using R1 by R2 is equal to under root rho 2 by rho 1, or R1 by R2 is equal to under root M2 by M1. We are going to use it to solve the problems. Note down, students. Suppose I'm going to consider if V is the volume of the gas diffused. If I'm going to consider V is the volume of the gas diffused, then how to define the rate of diffusion? Volume of the gas by T. What is T? V is the volume of the gas diffused in T seconds. Say I'm going to consider time is T seconds. Where what is T? Time. Time in T seconds. So if V is the volume of the gas diffused in T seconds, then what is the rate of diffusion? Volume of the gas by time. Here V is the volume of the gas. T is the time. That is the rate of diffusion formula. Then what happened? Rate of diffusion directly proportional to volume, inversely proportional to time. Then how to write the formula? R1 upon R2 is equal to V is the directly proportional, so V1 by V2 into T is the inversely proportional. That's why here 1 by 2 means reverse. Here 1 by 2 means here reverse 2 by 1. R is the R1 by R2 and volume is directly proportional, so V1 by V2. T is the inversely proportional to rate of diffusion. That's why reverse. Reverse means here 1 by 2 means here 2 by 1. T2 by T1. Here V1, V2 are volumes, T1, T2 are time, R1, R2 are rate of diffusions. This is also one of the formula we are going to using to solve the problems. Note down, students. Next one, Dalton's law of partial pressure. If I am going to consider a vessel, consider a gas X. Consider a gas X in it. So the gas exerts a pressure P1. The gas exerts pressure P1. And I am going to consider another gas. And its temperature I am going to consider some T. Now replace the X. In the same volume of the container, in the same vessel, I am going to replacing X. Take the Y. Same volume, same container, same vessel. Maintain the same temperature and pressure exerted by Y gas is P2. P2. If I am going to consider another gas is a Z gas, and temperature I am going to maintain same temperature at each and every place. The pressure exerted by gas Z on the vessel walls is I am going to consider P3. P3. If suppose take the same volume and take the same vessel, similar vessel with volume. Now consider all the gases X, Y, Z in it. X gas, Y gas and Z gas taken in the same volume and maintain the same temperature. As here, maintain the same temperature. At the time, the total pressure exerted by the mixture is I am going to consider P. According to Dalton's law of partial pressure, when I am going to take in all the gases, a mixture of gases in a vessel at the same temperature, the pressure exerted by the mixture of gases P, which is equal to P1 plus P2 plus P3. That means partial pressure component of